probably can go back to my traditional way of doing things with the actual big picture day, because they'll not be completely useless and waste of time-ish. Hopefully. Anyway, chapters, and this is kind of a big picture day for the rest of the book, but I'm just going to say it's for chapter 8 and 9. But basically we're just going to do chapter 8 today, but then really it's chapter 8 through 13, really, to be honest with you. It's all going to be about what's called hypothesis testing. Now there's going to be a variety of different ones, but they all have the same basic things in common. You are not this important. Put your phone away. I mean, I don't mean that in a bad way. Just ignore it. Just put it in your bag or something. Shut the ringer off. Just leave me alone. Just say that to them. Just leave me alone. Here, that's my new thing. I'm just going to start texting people this. If anybody ever texts me, I'm just going to text them this back. Leave me alone. Nice. Now, hypothesis testing. Now, here's the game. When we do this, as you know in life, we always make assumptions. Right? Now, as you know, when you make an assumption, sometimes you make an ass out of you and me when you assume. Yes, that's the traditional thing. But here's the deal. You always make assumptions in life. Okay? Now, you're walking down the street, let's say, and you're like, you see this gal walking on the street, and you're like the only two people on the street. Otherwise, you probably wouldn't have noticed her because she was like literally 4'5" tall. And you go, wow, that's weird. Why are you thinking that's weird? Because you have an assumption about the normal height of women is. Okay? When someone finishes a test is a huge test, like 200 questions, and they finish it in about an hour, and you're like, that's really weird. Why? Because like a normal person can't do that in an hour. Now your first thought, of course, is I bet they failed. But then they didn't fail. They were just really good. Well, that could happen too. Again, both cases, that's pretty freaking weird. Okay? Now, as we do this, what we're going to have is this. There's always going to be an assumption. This assumption we're always going to call H naught, which is what we call the null hypothesis. This will always be the setup. We'll have this null hypothesis. It is what we believe. Okay? It is, you could think of it like this, is what it ought to be. It ought to be. There you go. Ought to be, all one word? No, that's stupid. Ought to be. What it used to be. What it should be. Oops. What we thought it was. Etc., etc., etc. Okay? So, from years of experience, we feel like the average number of referrals per day is 10. I think it's changed this year. So we're operating under the assumption it's supposed to be 10. Why would I think it's changed? Because I don't know if I'm Mr. I almost said Carvalho, whatever they think. Hernley, right? I don't deal with him much. That's why I don't. Okay, first of all, I had to deal with Carvalho way too much. That's an understatement right there in itself. But I rarely speak to Hernley because I don't deal with freshmen and sophomores. Yes. So, as a result, I sometimes forget his name. But anyways, but if I'm Hernley and I'm seeing like, oh my gosh, there used to be like 10 a day, and now there's like 1 million a day, it seems like. Why does he feel like it's changed? Because he's in there. It's all about you. Okay, or in his case, him. He has an idea it may have changed. Now, it could be we just had a little rash of problems, yes, recently. Okay. It could be that we've just gone through a little phase, whatever. It could be that it's just the last 3 days there's been some little, like, I don't know, full moon or something passing through Aquarius or whatever up there, and you're like, oh my God, changing everything. Or it could be that things have actually changed. Here's a big word, friends, significantly. Mr. Groom will always refer to that as this, because I have a hard time spelling significantly when I'm talking. If I just write it out, I can write it. But when I'm talking, I try to spell it. And I'm like, what did I just do? I end up with a ficantly in there. Like I repeat part of it. It's ridiculous. So I just write sigly, and you may too. Okay? But the idea is, have things changed? Have they gotten better? Have they gotten worse? I don't know. Josie this year, Mr. Groom, based on the last few years of my time in running races and so forth, I think I should be able to run the cross-country doohoo in how much time? 18 minutes. But Mr. Groom, this year, all my times are down. It's down. They've gotten slower. They've got longer times. I've gotten slower. Whatever. Now, why is that? Well, I don't know. Are you injured? Yeah. Okay, there you go. We know why. Okay. Is it because you're just, whatever? Yeah, maybe. Are you having a few bad races? Yeah, could be. Could be. Could be. These things happen, yes? So, the game is always going to be about this. We are going to have some H naught. Again, this is the idea of what it ought to be, used to be, should be, whatever, what we thought it was, right? And then, of course, down here is you're going to end up having the alternative hypothesis, which is H1, the alternative hypothesis. And the alternative hypothesis is, well, the opposite. That's it. By the way, speaking of creepy, you see my website recently?
I don't look at your website.
Oh my God, you gotta see it. Oh. There you go. Hang on. I'm sorry, I just gotta show it to you, because why not? I'm pretty proud of this. 13 going on 50? Ouch, that hurts. It's pretty accurate, though.
Hi, how are you?
Wait for it. There you go. Oh my God, it kills me. Oh. Anyways. All right. Anyway, so. It's on you. You look on your phone yourself. Not later. Not now. Now, friends. Why not? Why not? Actually, I had a kid do it, and literally it takes as long to upload a picture as it does to have that. And I'm tired of looking at that one from me from last year with my giant shirt. I'm like, I thought about scanning my driver's license one in because I look like a serial killer in that one, so I thought that would be pretty cool, but whatever. Now, all right, now listen. Josiana. I'm going to write over here. Josie believes she is slower this year. And when she says slower, she means significantly slower. I don't know. She just believes she is. She used to run 18? I'm just going to say 18. I don't care. I'm going with it. I'm just going to go with it. Now, friends, what I heard she is slower. Now, that, of course, means greater than 18 minutes, yes? So down here, her average time is going to be greater than 18 minutes. That's what I heard. Now, the opposite of greater than 18 is what? Less than or equal to. Now, when we set these up, this is imperative. You should probably jot this in your old brain somewhere. Whenever we set them up, this one here is what we call an upper-tailed test. Because if you think about it, what I've got here is I'm going to end up having a normal distribution this time. Won't always be normal. This time it is. And look which way the arrow is pointing, friends. It's pointing to the upper side. Okay? Now, Mr. Grimm, could we set up one that was a lower tail test? Well, we could. What would it look like? Now, I'm going to use a different number so that you don't think I'm talking about Josie's one. This is a different one. It's Tracy. I don't think I'm going to do that. I don't know. Anyway, this would be an example you see of a lower tail. You see that? Because the arrow is pointing, to the lower side. In other words, this person's score has decreased or something. It's gotten worse. It's whatever. Okay. Or, in this case, maybe Josie's going faster. I don't know. But whatever. And then, of course, Mr. Grimm, could there be a two-tailed test where I say to you, I feel like it's changed. It's not what it used to be. It used to be 5. Okay. But it's not 5 anymore. Check it out. Not 5. Nah. Not equals 5. But what you'll notice, friends, whenever we're doing these, and I mean whenever we're doing them, the null hypothesis will always have an equal to component in it. Every single stinking time. Stream, I don't know which one to put where. Yo, if it has an equals in it, it goes on the null hypothesis. Every single stinking time. Okay? Every single time. Now, Mr. Green, will they always be normal distributions? No, it's a great question, Fiona. Thank you. No. Sometimes it'll be the t distribution. Sometimes chi-square distribution. What about, will we learn any new ones? Yes, we'll actually use the f distribution later on too. Right on, right on. So we'll use those four primarily, but there's not just those four. There's other ones too. Anywho, but they'll still be upper and lower tests. Okay, piece of cake. Yes. Now you're like, so is that all you're going to talk about that today, Mr. Green? Well, kind of. But listen, what it's going to be all based on is this. If I asked you, now we're going to shift. We're going to come. We'll look at Josie a little bit more later, her example. But for right now, let's just move on to something else. Yes, dear.
What was the one where it was like it's equal to or not equal to?
I feel like this is the it's a two-tailed test, dear. This is a lower tail. Thank you so much. This is a two-tailed. Ah, nice. How cool would it be to see a squirrel with two tails? Why is Mr. Groom so weird today? Because this literally Sunday was the first day I felt good in a week. Literally felt good.
Like good about yourself or just like feel good about yourself?
No, I don't feel good about myself. No, I just physically feel good. Physically feel good. No, I don't feel good about myself. No, heavens no. Now, friends, back up here. So, now, suppose I told you that just hypothetically, just for fun, suppose that the mean, this is, now remember who actually knows the mean? Only God does. There, he's also the one that cares, but whatever, okay? Let's suppose it was actually 10, just for grins, okay? Just for grins. And we take a sample and we find that the average is 13, and we find that the standard deviation of this sample is like 2. And how many were in the sample, Mr. Grimm? I think it's 50. Could you make a z-score for that? I feel like we could, yes? And so, by the way, what theorem allows us to do this? The central limit theorem. Well done. Well done. If someone would kindly crunch that number for us, that'd be swell. It's about 12-ish, I think. Seriously, so yesterday was the first day I actually felt good. That's why. And I haven't got to teach for like a week. It's just sad. Well, I kind of taught on Saturday, but not really. What?
Yesterday I got to sit on
That's no fun. How did you get? What did you get? A number?
I got 10.6.
That's close enough. All right, now, friends. Kaylee, if you got a z-score of 10.6, where are you on this thing? Right, remember, the Freakville starts at around 2 as a general rule, right? But you're out here at 10.6, for God's sakes, all right? Yes? What's the probability that you're further out in the tails than that? Well, I don't know. But I feel like we found that last week, didn't we? We actually found probabilities for some of that stuff. And it feels like, bear with me now, I feel like we could do the 1 minus the norm, you could say CDF or norm S dis, whichever your preferred method is, of course, yes? And then you would put in 10.6, and then a comma, a 10.6, well, okay, let me back up. I'm going to quit blending my more. Normal S dist 10.6 comma 1 if you're doing it on Excel or whatever, yes? Right? But if you're doing it on the 83, 84s and what have you, it's going to be normal CDF, right? From where to where? From 10.6 to infinity, right? And what does that come out to be in both cases? It's very, very small. Your calculator may just tell you it's 0, but it's really 0.00000 something. What is it?
1.52 to negative 46.
1.52 e minus 26. Okay? That is very small. Friends, this is what I want you to see today. Here's the dealio. When we look at these things, we're going to be paying attention to this number a lot. This has a name. It's called the p-value. Okay? It is the p-value. And here's what I want you to think about p-value. It is this. It is the probability that I saw what I saw given H naught is true. Okay? Which sounds like a lot of screwing around, but just go with me on this. There is a 0.000000000000000 whatever chance of that happening randomly from a sample of 40 people if in fact this is the true mean. Okay? Mr. Groom, are you saying, I don't know what you're saying, Mr. Groom. I feel like you're saying this. I feel like you're saying something to the effect of mu is greater than 10, mu is less than or equal to 10. Okay? So, again, in the real world, no one's going to know what actual mu is, yes? We are going to use this value from this null hypothesis. And so if that's the true value, the probability that we saw what we saw is some tiny little number. Well, now that means one of two things. Either we witnessed a rare event, or our assumption was wrong. Which is more likely? No, I know. Our assumption's wrong. Yes? So either you believe that what I saw is reality, I just witnessed something very rare, or more likely my assumption was wrong. Yes? Now, if you come back up to the original, if this is wrong, what must be true? It must be greater than 10. And not just greater than 10, significantly greater than 10. Okay? That's a big deal. That's how all of these tests will work that we do from now to the rest of the year. Okay? Now, we're going to take one moment. We're going to get out a purely normal deck of cards. Absolutely nothing special about these cards at all. I have to say that because it's a math trick. Okay? And I want you to think about this as we're doing it. I need an assistant. Fiona, thank you. Come up here and pick a card, any card. You're going to show the class. Okay? Pick a card, any card.
But not that one.
Oh, that's totally fine.
Oh, I'm picking this one.
Show the class. Somebody write this down what it is. Or keep an eye on it. What is it? Eight of diamonds? Eight of diamonds. Here, slap that back in here. Beautiful. Sweet. No. We're going to keep doing this for a while here. We need to select several cards. I just have to use a table. I can't do the whole bridgey thingy. Yes? Don't cheat.
You can't do the bridge thing?
No. I also can't palm a basketball, and I don't know. All right, here we go. Pick another one. I have these little lady fingers. I don't know. Mm-hmm. What is it? Ace of diamonds. Ooh, same suit, too. Weird. By the way, is that weird?
Not really.
What's the probability that we get two cards from the same suit back to back? This is not new, by the way. What is it?
0.25 times 0.25.
0.25 times 0.25, so 1/16, yes? Which is about 6% chance, which is not great. And if I got 3 in a row, I might feel a little weird about it, but not like, oh my God, I'll never believe that again. Mr. Groom, you must be cheating. But it's not impossible either. Here you go, give me that one. By the way, 1/4 is about 1.5%.
Dude, this is starting to get a little bit weird.
What'd you get?
It's starting to get a little bit weird.
Okay, that's weird. That is weird. I'm not going to lie to you. That's weird. So that's about 1.5% chance of that happening so far. Okay, I really suck at cards. Let me shuffle down here. Don't peek at my cards. Don't peek at them. No, go away. I'm not hiding anything. I just can't shuffle, but I don't want you to look at the cards.
Do you want me to shuffle?
No, I'm good.
You sure?
I just have to do it on the. No, I just have to do it on the table. No, I'll do it right over here. It's fine. I just need a table to do it on. It's just I have to do this kind of thing.
Okay.
All right.
I swear to God, if I get a friggin' diamonds, I'm gonna like cry.
Oh, for God's sake!
Oh my God!
No, I swear to you, they're not all diamonds. I promise you that. That's not the shtick.
By the
way, that is weird. Yes? I think we can all agree with that. Right? So that's 1/4 to the 4th power is
Something real
60.
tiny.
1, 2 out of 56. which is about 0.4% chance of happening, which is not good. That's weird. Seriously, that's not the gag. There is a gag here, but that's not it. All right, give me another. Give me another. There's one.
Okay, I gotta think about this for a second.
Technically not just nine.
Okay, we're good.
All right, what do we got? 9 hearts. There we go. 9 hearts. Now, what do we got now? It's 5 cards, yes?
Yeah.
5 cards? All right, here we go.
Okay, now we're on to hearts now.
Queen of hearts. No, 8 of hearts. 8 of hearts. 8 of hearts. You taking a video of me?
No, but it's a really cute picture.
Oh. The last time anyone said I had a cute picture was what? When I was 5, 3, I don't know, 2, maybe.
I have
don't
that
know.
cute one of you when you had like that
Cute one
like
of
teddy bear thing with the
yeah.
balloons.
Okay.
That was cute.
All right.
There we are.
We're back.
Now, how many cards is that, Connor?
1, 2, 3, 4, 5, 7.
All right. Nobody seen anything weird yet? Aside from the diamonds? Anything from the diamonds? Anything bothers anybody yet? It's all red. Is that a problem for you yet? Okay, why is that a problem? Okay, shh. Okay, that's a good call over here. Let's walk with that. So far I've heard we're all reds. And apparently my pen doesn't want to work. All reds. All reds in 7 draws. Okay? What's the probability of that? So 0.5 to the 7th power. Somebody crunch that out for me. 0.007. There's 0.007% chance of that happening randomly. Now, when you think about it like that, what is your thought then?
It's kind of weird.
That's weird. So what do you want to say inside of yourself there?
That this is rigged.
This rigged somehow. What do you mean?
I think you were shuffling the cards a specific way.
No, that's not true. I was not. What do you think, Haynes?
Oh, well, I saw 007 and so I thought James Bond.
Okay, cool. What about you, Naomi? This is a pretty small probability. What do you think about it? Does that bother you at all? You've seen smaller? Oh, okay, yeah. You're not impressed yet. All right, she doesn't impress easily. We're going more. Here we go. Pick another card. Oh my gosh, pick from a different side.
Still red.
It's still red. Now it's 0.0035.
Oh my goodness.
Anybody ready to call BS yet?
That looks like
Yeah,
a 6.
I've been told it since the first time you got up there.
They're
They're all red.
Are they all red?
You kept, I knew it. We're not dumb.
Rude.
Now, here's the deal. Why would you do that to us, Mr. Groom? Yes, please. Thank you so much. Thank you. A hand for my lovely assistant. Very lovely. Now, all right, now, you are under the assumption. We assume that half of the cards are red. Yes? Half of them. That's our assumption, isn't it? At some point, okay, I gotta need a new battery. My battery is no bueno. It's no bueno. Yes, I'm gonna get down this one first. All right, here we go. Here we go. We're back. Oh, we got the light. Shh. Now, here's the game. Shh. Well, can I have the back ones back on? No, other way. Shh. Now, so listen. At some point, why is this thing not? At some point, there is a probability that we reach where we call bologna sauce. Okay? Now, for some of us, apparently it's 0.0035, which is ridiculously small. I would have stopped way before then. In my mind, and in the minds of most of the big kids that do stats, the cutoff value is usually 0.05. That's pretty common. If the probability that something happened randomly is 5%, is less than 5%, then we say, you know what, I don't buy your H naught. It must be the other. But sometimes we'll use 0.01, rarely. And for those of you that are going to go into the touchy-feely world of psychology and stuff, you will see 0.1 a lot. That's mostly because people are weird. And whenever you're talking about people and how they feel and how they react, and talk to us about your pain tolerance or this or that or whatever, and the guy's got his freaking arm hanging off, and it doesn't hurt. It's fine. It's about a 2. It's a little uncomfortable, but it's not bad. Galaver's given birth, and she's just, how does it feel? Oh, it's about a 5. You're like, and some other guy who's got a little hangnail. It's a 10. Oh my God, I'm going to die. It's a hangnail. So with people, it's a little weird. So we use 0.1 usually, but that's just how it is. But these are these cutoff values. These values at which point we'll just say, no, I'm not okay with that. And we call them alpha. We call them alpha. Yes, a little fishy. And here's the game. If our p-value is less than alpha, we are going to reject H naught every single time. Every single time. Less than alpha, not less than or equal to, less than alpha. Okay? Shh. Thank you. Now, obviously, if it's greater than or equal to, we don't reject, obviously. It goes without saying, obviously, right? So, on the last case, right, at some point, Mr. Groom, 0.05, if 0.05 was our alpha, okay, how many red cards in a row would I have to get less than 0.05? Well, 3 red cards in a row has a probability of 0.125 of happening. So that doesn't bother me that much. 4 red cards would be 0.0625, which again it's marginally odd, but not terrible. But 5 red cards in a row at 0.03125. And at this point, you see that is less than alpha. So I'm going to have to call BS on the assumption that thank you, bologna sauce. What did I say? Did I say BS? Good, I hope so, because maybe the other one came out. Who knows? I don't know. Bologna sauce. We have to call bologna sauce on it. In fact, no, I don't think that they are all half and half. Does that mean they're all red? No. It means they're not all half and half, yes? That's a big deal. Okay, that's a big deal. In statistics, we never can say for certain it's this. But I can tell you what it isn't. I don't know what it is, but it's not that. Okay? That is the beautiful thing about stats. I don't have to prove anything to you in terms of what it is. I just have to prove what it is not. Okay? Now, that's a big deal. Now, I saw this trick first done by a friend of mine at a math conference one time with not high school students, not junior high students, with junior high math teachers and a few high school math teachers, which was really sad. Do you know how many red cards she had to draw in a row before someone called, hey, wait a minute, that seems weird? 8. That was the first time someone went, that feels weird. That was the first time. Nobody, I was watching their faces, nobody even went. I mean, because you could see the quiet people going, Nobody. Until 8th card came out, and they're like, is that a little weird now? No, it's a lot weird. It's a lot weird. Okay? So, again, when we're doing these, that is the game. We'll deal with p-values a lot. We'll say that idea that, hey, listen, we're going to set up some arbitrary, it's not really arbitrary, it's kind of arbitrary though. And the traditional one is 0.05. And any probability less than this happening, we're going to reject H naught because it can't be that. Right? I mean, it could be, but it would be very rare, yes? And I don't believe in rarity events. They're rare events because you never see them. Okay? If they happened all the time, then they wouldn't really be rare events. By the way, they'd have a higher probability too. Okay? Now, anywho, back to this. Another way to visualize this, for those of you who are visual people, is the idea of a courtroom. Okay? When you go to court, you are innocent until proven guilty, yes? You are innocent until I can reject your innocence. Yes? Nice. Do I have to show who killed the guy? No. I just have to show that you are no longer innocent. Could there have been somebody else? Maybe. But whatever. Now, here's the game. Let's put actuality over here. Oopsie daisy. Actuality. This is what's actually true. But again, only the guy who did the killing, maybe the person who's dead, and the good Lord know who actually is guilty, I guess, right? But whatever. The guy who did it is not telling. Okay? So here's H naught. Here's our decision up here. So again, we are either going to reject H naught or we're going to fail to reject H naught. We're going to just either stay with H naught or not stay with H naught. It's all about H naught. It's not about H1. No, sir. No, sir. What we're going to say to you is this. We found you guilty. And by doing that, we're rejecting your innocence. Yes? Or we failed to reject your innocence, which means I guess you're still innocent then, aren't you? Okay. And so our decision will be either to stay with H naught. By the way, if you are innocent and we decide that you're innocent, hey, this is true. This is good. We like that. These are not the same size squares, are they? I hope not, because that'd be 25% of the time, and that'd be a problem. We would like this to be a large chunk of the time that we get the decision correct. Okay? So don't worry about that. Now, what if the guy was actually guilty, but we found him innocent? Would that be a problem?
Yes.
So this is error. Is this a horrible error? Well, what happened to this man? He was guilty, but you let him off. This is O.J. Simpson. Yeah, okay. This is a variety of other situations, perhaps, right? Where the dude, you're sure that, okay, everybody knows but somehow he got off. Technicality, what have you. Okay? This is a problem. I don't know what's the worst problem. Here is another problem where the guy was truly innocent and we hung him. This is a problem. Which of those is a worse problem?
The one you hung.
This one. And we call this type 1 error. It's the worst, obviously. You can't really fix that. Let's unhang the guy. Okay, it's no bueno. Yeah, so the chances that we make this is the probability of that happening. The probability of a type 1 error is alpha. You see that? It is alpha. So we only have a 5% chance, you see, of making a type 1 error, which is very small. Because we don't want to do that. That's why they say when you're on the jury panel, we want to prove the guy is innocent guilty beyond a shadow of a doubt. Yes? In other words, very small probability that we're wrong. Okay? Type 2 error, you can't really control for type 2 error. That's just how life goes. But type 2 error, there it is. Now, what if he's guilty and we find him guilty? Again, this is true, yes? But again, we will always either reject H naught, okay, or we will fail to reject H naught. We will never say we're going to accept the alternative. OJ got off. I'm not happy about that. I'm not going to accept it per se. It just is what it is. Okay. What we'll end up saying is this: reject H naught, something like this, and then we'll say like Josie. Josie is significantly slower, or something. Significantly slower. We will actually always refer it back to, you see, the story from whence it came. Every single problem will have a little story that goes with. Okay? Every single story. And so when it's all done, let's go back and refer it back. Okay? Now, Connor believes, here's a little story. We're not going to actually do the math on this one per se. Connor believes the percentage of people involved in skits has decreased. I don't know. Used to be 40%. I don't know. I'm just making that crap up. Whatever. So what I'm hearing is this. These are actual percentages. Whatever. So P, I got 40 and 40. Which it's decreased. So what am I hearing? I'm hearing less than. You see this? That's what I'm hearing. That's the picture I'm hearing. Later on, we're going to tell you how to make a z-score for this, but I'm just going to go and tell you what the z-score is right now. It's negative 1.72. Right? I just pulled that out of my hat. You don't even know where it came from yet, but we'll talk about it later. I'm just saying. Negative 1.72 is over here. You with me on it? Oops. What's the probability that you're from here down? I don't know. I bet we can find it, though. Normal CDF. Negative E99. Common negative 1.72, right? And let's just say we have an alpha of 0.05 here. What does that come out to be? Point. What?
Oh, for the percent?
Yeah. P-value. Yeah. So what is it going to be? 0.0.
0.042.
Yes. Thank you. Oh, yes. 0.04. Yes, it is. Yes, it is. You had me fooled for a second. There it is. I love it. Hey, there's my p-value. Yay! If I was doing this on my calculator, what would I do? I'd do normal s-dist, right? Normal s-dist or whatever. And I would just simply put in negative 1.72, right? Comma 1 or not comma 1. I can't remember what it is on your Google Sheets, right? And it would be 0.042, right? Yay! Now, look at this compared to alpha. What is it? Oh my gosh, it's less. So what should I do? So I should reject H naught, yes? Whoosh. Reject H naught. Now, what does that say about Connor? Is he right or wrong? Read the problem.
He's right.
He's right because he said it has decreased. Yes? Connor's right. That a boy? Yay! Blah, 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 has decreased. Yeah, yes. Significantly. The percentage has decreased. Big word. Sigly. Nice. Oh, okay. That's it. We'll play this game over and over and over again. Now, could Connor up here, could Connor believe that it is not changed, that it is not, it has stayed the same or something like that? Connor could have said that. Connor could have bet on this horse. If Connor would have bet on that horse, he would have been wrong. You see this? The book talks about the claim. If you're one of these people who read the book, which I hate to say I don't encourage you to read the book, because I do encourage you to read it and look it over a little bit. But I understand that you can bet on whatever horse is running the race, yes? Whether you bet on them or not has no impact on whether they win, yes? Like literally, I did not watch one down of NFL all this year, and that includes the Super Bowl. Now, the NFL, had I been tuned in to the Super Bowl, would it have had any impact on the outcome? If I'd have been really upset about Tom Brady winning, would it have had anything to do with it? No. In fact, he might have won even more. But whatever. Life goes on. So you can bet on either horse. So please, for goodness sakes, always talk about this first. Reject H naught. Then go back to the story problem. Connor's right. No, Connor's an idiot. No, whatever. And then finish it off with, it has decreased significantly or whatever. From there. Now, we will be doing this all the rest of the year. We'll be doing hypothesis testings like this. We'll do it for means. We'll do it for proportions like this one here, which we didn't actually look how to do it, but we just talked about it. We'll do it for standard deviations and variances. We'll do it the mean height, mean whatever of girls versus the mean height for boys, or IQs or whatever. And like, oh my God, there's no difference in the IQs of boys and girls. Whoa, who saw that coming? Wait for it. There might be a significant difference in the variance of IQs in boys and girls. Okay? Is that bad? I think boys have a higher variance? No, that means you got the haves and the have-nots more so, yes? Whereas the ladies tend to be maybe a little more grouped. Who knows? Just made that up. So, we'll do it for multiple populations. We'll do all kind of good crap. But it'll all come back to this hypothesis testing. Okay? All right, I'm done talking. Tomorrow we pick it up from there.